same size as other knobs used in electric guitar, so they'd be similar for them to be familiar to guitar users. And they're out of the way of the back of the guitar, so there's no way that the user could accidentally hit it, turn it off, or turn it on or off, or turn the tuning when it's not meant to be turned. You see in the middle, the orange, there are the custom-made adapters for the motors to attach to the tuning pegs, and on the bottom of the screen or the top of the enclosure is the PCB, which is hooked up backwards so that all the motors and user interface can easily hook onto it. And it is secured with screws onto the top so that no matter how hard you're playing standing or sitting, there's no accidental jarring and nothing comes unhooked.
And just a little bit on the level of success of our project. We were able to accurately detect the frequency coming in through the guitar to within a few hertz, then send it to the motor signals. The motors turn the correct way and stop when they're in that window of plus or minus 1 hertz of the correct value. What we haven't gotten a chance to do yet is, it was always our intention to put it all on one string first, test it, and make it as accurate as possible before adding it to the other strings. So currently we're only tuning one string. Also, there's a little issue where when we're tightening up, there's a lot of tension on these strings. So these motors need to have a very high torque value. Unfortunately, when we have to loosen the strings, the torque disappears. So it has a tendency of going too far, loosening, and then having to come back again, and eventually it stops. It's still, speaking from experience, a lot easier than tuning a guitar yourself and trying to listen to it, but it's not accurate on the first time, but that's the feedback nature of the project. Questions?
I noticed that you mentioned that you already bandpassed the signal from the pickup. Why do you need to then time the zero crossing if you already know? If you can bandpass the signal, don't you already know the frequency that's the signal?
We know a general range. That's what the bandpass is doing. It's basically, there's 6 inputs for each string, but it's basically making sure that there's no noise coming from another string, that what we're looking at is that range of the string. It's not able to accurately tell what frequency is. That's why we're not doing it.
I have 2 questions. First of all, I may have missed it in your talk, but what's your absolute frequency standard here?
What do you mean by absolute frequency standard?
Well, you're measuring the frequencies of the strings, right?
Yes.
So you need to have a stable, well-known time base with which to compare the strings. What is your time base?
We're counting the amount of zero crossings in a quarter of a second.
Well, how do you know how long a quarter of a second is, I guess is my question.
There's an onboard clock in the microprocessor that counts it. And
how does it keep time?
Based on the clock on the microprocessor.
Well, how do you know that clock is accurate?
Because it accurately detects the frequency.
I'm seeing a circular argument here.
Yes, we're counting in about a quarter of a second, and we tested it and we adjusted it so that it accurately detects the frequency.
Well, can you sing?
Can I sing?
Can you sing the note middle C?
No.
Right, because you need a standard. So you need an absolute standard. How accurate is the microprocessor standard?
It detects the frequency to within a half a hertz.
Okay. And secondly, how heavy is this thing? If you gave it to a guitarist, would it make the guitar tilt to the left, or is it lightweight?
It's no heavier than a Les Paul. Les Paul really.
Sorry, than a what?
It's no heavier than a Gibson Les Paul, which is a really, really heavy guitar. It's lighter than that. So.
Very interesting. Nice job.
A lot of our weight concerns were solved by making it a travel size guitar. It's a lot of the excess stuff that comes on certain guitars are eliminated. So we can put all this hardware.
Very good. Thank you.
The harmonics of one note might be mistaken for another note. How would your system deal with this to avoid adjusting the string that you're not actually strumming?
There's each individual string actually has its own individual pickup routed to the microprocessor.
But you mentioned that you needed the filters to avoid picking up the signals from another string, but
Yeah, that was just an added level of denoising it. Basically, what the filters are doing is we have one string per input, and it's taking out the harmonics of each string. So there's 6 inputs to the guitar. Each of that is the bass frequency for each string.
And each string is being strummed individually, so that's why you have the outputs from 6 strings from the pickups going directly into 6 filter circuits, and then that output is going to the
so do you have to specify which string you're strumming?
No, because it's directly going, if it's strumming a string, it's going directly through a circuit, it does a different filter circuit into the CPU board.
Well, my point is that when you're strumming, let's say, one string, it might be mistakenly picked up by a sensor for another string, and a harmonic of it might match that of the other string, and in turn it might mess up your tuning for the other string.
It's assuming that these guitar strings that are out of tune are not so out of tune that their frequency might be matching the different strings.
Well, not the primary, not the principal frequency, but a higher harmonic might match.
The way the piezoelectric pickups that we use work is that there's a specific line for each string. So it's pressure based, so it doesn't pick up another string's harmonic on that input, even if they, are close.
So you let the string next to it when it's moved down lower. Back more.
I have a question. There was one question about how much does it weigh. Your one picture there looked like it was on the back of the guitar. Wouldn't that kind of get in the way of when you're strumming the thing, it kind of catch on your jacket or something?
It's sizable, but it's not completely. It's no bigger than a big full body jumbo acoustic. You can sit there and it's about right here.
How deep is it?
It's about that deep, I would say. So it's
15 like 9 centimeters.